There is a dump truck on today's list that costs $7 million. Not a fleet of trucks, one truck. A single machine that weighs more than a fully loaded Boeing 747 carries 450 tons of material in a single load and burns through enough diesel in one shift to fill a standard car's tank 40 times over. And the company that built it had to design tires specifically for it because nothing in existence was large enough. Today, we're going through the 10 most expensive dump trucks ever built. The machines that move mountains literally and cost as much as a private jet to put on a job site. The prices are hard to believe. The scale is harder. And the engineering behind the most expensive one on this list is the kind of thing that makes you wonder how it's physically possible. Stick with me, because by the time we get to number one, and your idea of what a vehicle can be will not be the same. Most people have seen a dump truck, the kind that holds up traffic on a construction site, drops a load of gravel and moves on. That machine carries maybe 20 tons. The vehicles on today's list carry between 150 and 450 tons per load. They operate in mines so large they're visible from space. They run 24 hours a day, 7 days a week, in conditions that would destroy conventional equipment in weeks. And they cost anywhere from $1 million to $7 million each, before you factor in maintenance, tires, or the specialized roads that have to be built just to support their weight. 10 machines, each one more expensive and more extreme than the last. The one at number 2 is the reason modern mining exists at the scale it does. And number 1 is something else entirely. The Volvo A60H. Entry point on today's list. And even here, nothing about this machine is ordinary. The A60H is the largest articulated dump truck Volvo makes, and at $738,000 it represents the most accessible price point we're covering today. Accessible being a relative term. The A60H hauls 55 metric tons per load. Its articulated chassis, meaning the front and rear sections pivot independently, gives it maneuverability on soft terrain that rigid frame trucks can't match. Operating in mud, sand, or unstable ground where a rigid machine would sink, the A60H keeps moving. The engine is a Volvo D16 inline-6 producing 684 horsepower. The automatic transmission has 8 forward speeds, and the bed tips hydraulically in around 15 seconds, fast enough to keep a crusher or processing plant continuously fed. What makes the A60H expensive isn't exotic engineering. It's precision, the chassis tolerances, the hydraulic system, the drivetrain integration that lets it run 20 hours a day in punishing conditions without failure. In large-scale quarrying and construction, downtime costs more per hour than the machine does, so Volvo built one that doesn't stop. Price approximately $738,000, the cheapest entry on this list, and already more machine than most operations will ever need. The Komatsu 830E. Step up in scale, and the numbers change fast. The 830E is a rigid frame haul truck. No articulation, designed for the stable, graded haul roads of large open-pit mines. It carries 205 metric tons per load. That's nearly 4 times the Volvo. The engine is a Komatsu or GE option depending on configuration. Diesel-electric drive, where the diesel engine generates electricity that powers individual electric motors at each rear wheel. No mechanical transmission, infinite torque response. The rear wheels each receive independent electric drive, which means traction control and power distribution happen electronically rather than mechanically. Payload capacity per shift in active mines, upward of 4,000 tons. One truck, one 12-hour shift. 4,000 tons of ore-bearing material moved. The 830E costs approximately $1.5 to $2 million depending on specification. Multiple units operate simultaneously in the world's largest copper and coal mines, in Chile, Australia, and North America. When a mine orders these machines, they don't order one. There they order a fleet, because the economics only work at scale, and at scale, these trucks are what make the numbers add up. The BelAZ 75601. Belarus is not a country most people associate with record-breaking industrial engineering. The BelAZ 75601 is a reason to reconsider. Produced by the Belarusian company BelAZ, the 75601 carries 360 metric tons per load and weighs over 560 tons fully loaded. The engine, a diesel-electric system producing 3,500 horsepower, drives electric wheel motors at each of the 4 rear tyres. The tyres themselves are over 11 feet tall. The truck is approximately 47 feet long and 29 feet wide. It cannot fit in a standard 2-lane road with room to spare on either side. It doesn't need to. These machines operate exclusively on purpose-built mine-haul roads. Now, it's engineered specifically to support their weight and designed for the single-direction circuits that maximize their efficiency. The cab sits roughly 16 feet off the ground. Access requires a 3-stage staircase built into the frame. The operator's view from the cab looks down onto terrain the way a pilot looks down from a cockpit. Cost: approximately $2 to $2.5 million. BelAZ is not a well-known name outside the mining industry. Inside it, the 75601 is considered one of the most cost-effective haul trucks at this payload class in the world. The Belarusians have been building these machines since the Soviet era. They know exactly what they're doing. The Hitachi EH5000AC3. Hitachi's largest production haul truck and one of the most technologically sophisticated machines on this list. The EH5000AC3 carries 296 metric tons. So the AC in the name refers to the AC electric drive system, alternating current motors at the rear wheels, driven by a diesel generator, offering more precise speed and torque control than older DC systems. What that means practically: smoother operation on steep grades, better energy recovery on downhill hauls, and lower maintenance requirements because AC motors have fewer mechanical wear points than their predecessors. The engine is a Cummins QSK60. 60-litre displacement, 2,700 horsepower. For reference, a Ferrari F8 Tributo produces 710 horsepower from a 3.9-litre engine. The Hitachi's engine is 15 times larger and produces nearly 4 times the power. The payload bed is designed for easy liner replacement. The steel liners that protect the bed from impact wear can be swapped in the field without specialized equipment, time-reducing downtime in operations where the truck runs around the clock. Price: approximately $2.5 million. Multiple units operate in the massive iron ore and coal mines of Australia's Pilbara region, where fleets of EH5000s move more material per year than any other single category of equipment on Earth. The Terex MT 6300 AC. Before Terex was acquired by other interests, this was their flagship, and it remains one of the most capable haul trucks ever produced. The MT 6300 AC carries 400 metric tons. The engine is a GE diesel-electric system producing 3,750 horsepower. The truck weighs 260 tons empty. Fully loaded, it exceeds 660 tons, heavier than an Airbus A380 at maximum takeoff weight on 4 wheels, moving across a mine haul road at 40 miles per hour. And the payload bed on the 6300 AC is one of the largest in the industry, designed with a low center of gravity to reduce rollover risk on the banked curves of mine haul circuits. The cab is fully pressurized and climate controlled, with active noise cancellation reducing the interior sound level to that of a standard office environment. Outside, the twin diesel exhausts produce a sound that operators at the other end of a mine pit can hear clearly. Price: approximately $3 million. Fewer of these exist than the Komatsu or Caterpillar equivalents. Terex's haul truck production was more limited, which makes the ones currently operating in active mines something closer to rare industrial artifacts than standard equipment. The Liebherr T282C. German engineering applied to a machine the size of a house. The Liebherr T282C is one of the manufacturer's largest haul trucks. 400 metric ton payload capacity, diesel-electric drive with a Cummins or MTU engine producing up to 3,650 horsepower. What distinguishes the T282C from competitors at similar payload ratings is the suspension system. Liebherr engineers a hydropneumatic independent suspension on all 4 corners, which is unusual at this vehicle class. The result is a truck that maintains more consistent tyre contact with the haul road surface, improving traction, reducing tyre wear, and extending the life of the haul road itself. In a mine where haul road maintenance costs millions per year, a truck that's gentler on the road surface has real economic value. The body is made from high-strength steel with a distinctive V-shaped floor that concentrates load toward the center, and improving stability and reducing structural stress during dumping cycles. Cost: approximately $3.5 million. Liebherr sells these into mines across 5 continents, and the engineering that makes them distinctive, that independent suspension, the V-floor body, the Liebherr-designed drive systems, is the reason operators who've run both will often specify the T282C when they have the choice. The Komatsu 980E4. Komatsu's most advanced haul truck and the machine that pushed the boundaries of what diesel-electric drive could do at extreme payload ratings. The 980E-4 carries 360 metric tons. The engine, a Komatsu SSDA-18V170, is an 18-cylinder diesel producing 2,700 horsepower in standard configuration, with some variants optioned higher. But the number that matters most on the 980E-4 isn't horsepower, it's the drive system. Komatsu's AC drive uses dynamic braking. On downhill hauls, the electric wheel motors become generators, converting the truck's kinetic energy back into electricity that feeds the braking resistors. On long downhill grades in deep open-pit mines, this means the truck's brakes experience dramatically less thermal load, extending brake life and reducing the risk of brake fade on steep descents. It also means the truck can maintain controlled speed downhill without mechanical brake application, which is how fully loaded 360-ton machines stay on haul roads without incident. Price: approximately $3.5 million. Komatsu operates an extensive global support network for the 980E4, which matters when the machine is running in a remote mine and a failure costs the operation $50,000 per hour in lost production. The Caterpillar 797F. And the truck that defined what modern ultra-class mining looked like when it entered service, and the machine that Caterpillar built their entire large mine equipment strategy around. The 797F carries 400 metric tons. The engine is a Cat C175-20, a 20-cylinder diesel producing 4,000 horsepower. It is one of the most powerful diesel engines ever fitted to a wheeled vehicle. The transmission is a mechanical unit, 7 forward speeds, which is a deliberate engineering choice by Caterpillar at a time when competitors had moved to diesel-electric. Cat's argument: mechanical drive is more efficient at the sustained high speeds of long-haul circuits, and the transmission's simplicity means lower maintenance costs over a machine's operating life. The 797F is 47 feet long, 29 feet wide, and the operator's cab sits 26 feet above the ground. The tyres are 13 feet tall. Each one costs approximately $42,000. The truck runs 6 of them. That's $252,000 in rubber alone, before the first load is ever carried. Price for the machine? Approximately $5 million. More than 179 7Fs currently operate in mines across North America, Australia, and South America. And in the mines where they run, they are the single largest capital expenditure on the equipment list, by a significant margin, the BelAZ 75710. This is why we're here. The BelAZ 75710 is the largest, heaviest, and most expensive wheeled vehicle ever built. It is not close. The payload capacity is 450 metric tons. The truck itself weighs 360 tons empty. Fully loaded, it reaches 810 tons. Heavier than any aircraft ever built except the Antonov AN225. The machine is driven by 4 16-cylinder diesel engines working in pairs, and generating electricity that feeds 8 electric wheel motors, 2 per wheel, 4 wheels total. Combined output: 4,600 horsepower. The tyres are 13 feet tall and took Bridgestone over a year to develop specifically for this machine because nothing in existing production met the load requirements. 8 tyres, each one bespoke. The truck is 67 feet long and 32 feet wide. The cab contains 2 operator stations because the machine is so wide that a single centered operator position cannot provide adequate visibility on both sides simultaneously. 2 people sit in the cab, each monitors their side. At full load on a mine haul circuit, the 75710 moves at a maximum of 40 miles per hour. It takes over 100 feet to stop from that speed. And the haul roads it operates on are engineered to carry its weight and nothing else. If a standard vehicle crosses the same road, the surface deteriorates immediately under the load differential. Price: approximately $6 to $7 million depending on configuration. BelAZ built the 75710 to prove something: that the limits of haul truck design had not yet been reached, and that a Belarusian manufacturer working outside the conventional industry hierarchy could build the most extreme machine in the category's history. They were right, and there is currently no wheeled vehicle anywhere on Earth that carries more, costs more, or makes everything around it look smaller. 10 machines. A $738,000 articulated truck that runs on soft ground where rigid machines sink. A $7 million Belarusian machine that carries 450 tons and required custom tires that didn't exist before it did. And everything in between. Diesel-electric systems, 4,000 horsepower engines, tires that cost more than most cars, and price tags that start where luxury supercars end and keep climbing. What every machine on this list has in common is the same thing that drives every extreme build we cover. The job required something bigger, so someone built something bigger. The mines got deeper, the payloads got heavier, the haul roads got longer, and the machines got more expensive with every generation because the alternative was leaving material in the ground that someone needed. Now I want to know, which one stopped you? The 797F at $5 million. The BelAZ 75710 at 7. Or the one that surprised you by being more capable than you expected for what it cost. Drop it in the comments. I read every one. If any of these machines did something for you, hit that like button. It helps this video reach the people who've never seen machines like this and need to. Subscribe because we find these every week and the next list is already built. And if the scale of these trucks caught you, the payload numbers, the engine output, the price tags, you need to see what the world's largest mining excavators look like when they're loading these trucks. We're talking machines with buckets large enough to hold a school bus, shovels that cost $12 million, and excavators so large they have to be shipped in pieces and assembled on site because they cannot be moved any other way. That video is right here. See you there. See you there.